Hello, everyone. Welcome to the HAProxy 2.8 feature Roundup webinar. My name is Eric Martinson. I'm a solutions engineer here at HAProxy Technologies. And today I'm going to walk you through some of the new features of HAProxy 2.8. There's a lot of items to cover today, so let's just dive right in. Now, in terms of housekeeping, you can ask questions on the questions panel at any time. They will be answered at the end of the session. And if we run out of time, we'll follow up with you directly. Now, as usual, this webinar is recorded and will be sent to you in a few days. In terms of agenda, today we're going to cover several topics. First, we'll do a quick introduction to HAProxy, then move on to the updates in version 2.8, such as Lua, some new default settings and multi-threading enhancements, and then follow with a Q&A session at the end before we wrap up. So, introduction. We wanted to start off with an overview of our HAProxy philosophy as we deploy and create software. One of the key items for us is simplicity. Anyone should be able to read and understand a configuration. And to do this, one recommendation is that each configuration be documented to help someone in the future understand its logic. But for the most part, it's very easy to read. High performance is our #1 priority, and we do this by using a high performance event-driven model and lock-free multi-threading. In terms of reliability, we have 2 releases per year. Even releases such as 2.8 are long-term support, and odd releases such as 2.7 are supported for about 1 year. Backward compatibility is extremely important to us, so most pre-2.0 configurations are still valid in 2.8, and we try to deprecate warnings a long time in advance so that you're aware of those things. And because the proxy is a main entry point to your platform, it's extremely important to have observability as a key component. Many metrics can be collected using the stat socket, logs, or the Prometheus exporter. And the default log format provides the most information to diagnose an issue for each request. There's a huge amount of documentation on this, so please consult that to understand all of the fields available. And then finally, HAProxy is expandable with Lua and SPOE, or Stream Processing Offload Engine options. Again, that's something that's very detailed and complex, so it's something that you should check our website for more information on. We will be going over some Lua script updates, so that's a pretty cool feature update for us. In terms of the HAProxy ecosystem, it consists of several components. So there's the load balancer itself. Today we're talking about the features of that in the 2.8 release. There's the data plane API, which is able to configure the load balancer via an API-oriented interface. And there's a Kubernetes ingress controller, which gives you a way to route external traffic into your Kubernetes cluster and providing features from HAProxy, such as load balancing, SSL termination, rate limiting, logging, and other features. Like I said, HAProxy uses an event-driven model, which is incompatible with blocking processing. So we do have a stream process protocol offloading engine to help offload heavy processing tasks to an agent without impacting performance. And then, of course, Lua scripting language is also part of the ecosystem. At HAProxy, we obviously are built on and love open source technology, and we encourage contributions from everybody. If you have developed a new feature, we would love to be able to add it into our code base. But if you're not a developer, we still encourage you to contribute in many ways, either through documentation, which we always try to make as exhaustive as possible, but it can always use improvement and clarification. Or as an experienced user, you can share your knowledge with our community in our community discourse, Slack, Reddit, Stack Overflow, etc. Please do not be shy about sharing blog posts, tweets, and talks, and any kind of other documentation that you have, we would love to share that as well. Now, on to the updates. First off, we're going to touch on the Lua feature updates. Now, if you extend HAProxy functionality by writing a Lua module, that module can now take advantage of the new event framework. And now, Lua could already hook into HAProxy a number of ways, including actions that authenticate, validate, or alter requests and responses on the fly, services that intercept traffic and immediately return a response, and tasks that run continuously in the background, as well as custom fetches and converters that capture and transform data as it passes through. The event framework augments all of that by letting you subscribe to events and then invoke a callback function when those events fire. The core event sub allows you to subscribe to events that occur across all servers, and the server event sub just on specific servers. Here you can see events such as when a server is added or removed, its state is up, down, or changes, and goes through an admin state such as drain mode. Custom Lua modules can also now leverage new functions for accessing information about backend servers. So you can now pull information such as its name, unique ID, whether it's a backup or added at runtime, data such as current sessions and pending connections, and tracking info, or even register a function that will be called on a specific server event. Now, in terms of performance, when you're running those scripts, sometimes you find situations where your script either doesn't finish or trigger a yield, and that can impact performance. So the new directive, tune Lua burst timeout, squashes those problems that really, where the Lua script takes too long to execute. It kills them after a period of time with a default period of 1 second. And this safeguards the load balancer from locking up while waiting for a script to complete, and could also help locate custom modules that need optimization. You can disable this setting by setting the value to 0. Also, you can disable the creation of the default resolver section that's added if your Lua makes HTTP requests. So the default behavior since 2.6 has been to generate the DNS resolvers by parsing the etc resolve conf file. And this option gives you the ability to take that out and disable. So by just using the resolver disabled as on, you can now disable that feature. Also available with 2.8 is the introduction of queues. So your Lua code can now utilize queues, which is a first in, first out storage. And this helps you transfer data between coroutines. Lua itself does not provide such a structure, so this is a great addition for that within HAProxy. And the email alerts module, which we'll go over next, provides an example of using a queue. It adds an alert message to a queue when a server event fires, and then that separate background task fetches messages from the queue to send them as email notifications. Central to this feature is the core.queue function, which returns a queue object, and that's highlighted here. This is an example from the Lua script that we'll cover next. So like I said, email alerts have been given a new life because they've been recreated as a Lua module. As this Lua module, you can more easily edit the code to customize the format of the emails and also add extra relevant information such as links and additional on-call personnel. So you can send emails to multiple recipients, which is a great addition. And because it's a Lua scripting language, you can edit this file with the text editor, save and restart the service, and changes will be in effect. HAProxy can notify you by email then when an important server state changes occur, such as when HAProxy removes a server from load balancing due to failing health checks, or adds it back due to passing health checks. The syntax for configuring email alerts is staying the same as in 2.8, but the underlying implementation previously as a C code is now duplicated as a Lua module. So it's as simple as adding a Lua directive in the global section, and this will disable the default C configuration. You can download the Lua link at the bottom of the slide. It's also in our blog post where we announced 2.8. And the default section sets up the email alerts, and the mailer section sets up the addresses of your SMTP servers, just as it is today without Lua. So it's quite a simple setup and very easy to implement. Gives you a lot more features and allows you to extend email alerts with Lua. It's a very exciting update. Now the next feature we want to cover is HTTP compression. So with version 2.8, we've expanded our HTTP compression feature so that you can now compress requests in addition to responses. So you can, the request compression aids the transfer of large data sets to backend servers, which can save you money in cloud environments where you pay for data transport. This new syntax has you specify whether you want to compress requests, responses, or both. So in this example, we want to compress JSON sent to the server. So we configure HAProxy to compress requests that have the content type header sent to application JSON. And that's highlighted here with an arrow. So it's quite simple to set up. There are also several features that have new defaults. So one of the first is ALPN, or Application Layer Protocol Negotiation, which is a TLS extension that lets a client and HAProxy agree on a mutually supported protocol that they use for communication. It's how a client can switch from HTTP 1.1 to HTTP 2 without switching to a different port. So exchanging this info during the TLS handshake saves a network round trip. So this new default value tells the client that HAProxy prefers HTTP 2 and HTTP 3, but can fall back to 1.1 if the client doesn't support them. You can also disable ALPN by adding a no ALPN argument to the bind line. So some examples, as you can see here, with the default configuration, you do not have to specify ALPN at all. It will automatically default to H2 with an HTTP 1.1 fallback. Now, bind lines that use the quick protocol will get the default ALPN value H3. And to disable ALPN, you just use the no ALPN argument. So very straightforward in terms of defaults. We've also updated HTTP in response to RFC 7239. So when you need to forward request context such as client IP address, protocol, etc., the common solution for that has been using an X forwarded for header. And while this works and is widely deployed, it was never officially supported by IETF and can cause some issues because of that. So HAProxy 2.8 adds a new option as a forwarded header for request, which is in response to the RFC. It makes it simple to pass client information and information from the HAProxy server that handled the request to those backend servers. To enable it, it's just a simple option forwarded directive that enables the header. And you can also configure it with the header fields automatically, or define expressions that generate the values in custom ways, as you can see here. You can do either the generic value that comes across, such as host, or you can do it with a expression with host expression. And here we got host, by, and for, and by port and for port options. Some examples of this, in the default setup, you can just set up option forwarded. And as you can see, the resulting header here just has proto and the for items in the header. But if you want to get more complex with it and add some customizations, The example 2 gives you the request host and then a hashed client IP address and client source port. So that's as simple as using the option forwarded with the host option, and then the for expression option, which gives you the ability to add that source with the hex code. In addition to generating a forwarded header, we also add new converters in 2.8 for validating and extracting information from that header for the incoming request. Since that header is defined by RFC 7239, that naming convention follows that. Some of the examples here are at the bottom of the slide. Example 1 shows an ACL where the isValid converter will come back as either true or false if that header is a valid RFC 7239 compliant header. And then example 2 shows a setting with a variable from the forwarded header, in this case, the forward for. And obviously you can use other items in this table to do different things within your configuration as you require. We also want to provide an update for WolfSSL. WolfSSL is a TLS library that is gaining in popularity due to its size, speed, and feature set. And we've been working on it, so we wanted to give a progress update on where we stand with the integration. Overall, a lot of progress has been made to support WolfSSL as a TLS library. And HAProxy has been working very hard on this because WolfSSL has built-in support for Quick, shows very good performance, and is up to 20 times smaller than OpenSSL. Our engineers continue to work with the WolfSSL engineers to iron out missing features. And while this integration is still in development, you can expect a fully working version in the near future. If you'd like to test the current version, you can find the install guide in the HAProxy GitHub. Now, because performance of HAProxy is always top of mind here, this release gives you a few tools that simplify multi-threading and helps you get the best performance out of your resources. So version 2.8 adds the ability to add a CPU map argument, and you can define multiple comma separated CPU sets to be able to accomplish this. On most operating systems, it's possible to bind a thread group or a thread to a specific CPU set, and this helps you do that. This means that designated threads will never run on other CPUs, and the CPU map directive specifies that. The first argument is for a thread group range, optionally followed by a thread set. So if you look at example 1, this binds all threads of the first group on the first 4 CPUs. And when you look at example 2, you can bind each thread to exactly 1 CPU using all, odd, or even keywords. There's also an additional global directive, which called a multi-queue, which gives you more control over how work is distributed among the threads assigned to a listener. This default value is on, and it sends work to the least busy thread. Setting this value to fair distributes connections to threads in a round-robin rotation, and that suits traffic that's consisting of short-lived connections. There's also a thread argument added, so that this restricts the list of threads on which this listener is allowed to run, and it does not force any of them, but eliminates those which do not match. So it limits the threads allowed to process incoming connections for this listener. The main purpose of this is to have multiple bind lines sharing the same IP and port, but not the same thread in a listener. So the system can distribute the incoming connections into multiple queues, and it bypasses HAProxy internal queue load balancing. Also, in this release, we have the hot size global directive, which allows you to set the amount of memory kept for each thread. Now, normally the default amount of 512 kilobytes should suit most, but this gives you the option to set the number of memory if you need to. There's also an experimental global directive that disables data fast forwarding. Now, this is recommended to only use when directed by project developers because it is still experimental, but it is an option with this new release. Another addition to help with multi-threading performance is an update for listener sharding. So HAProxy 2.5 introduced a shortcut called shards for defining multiple listeners or bindlines in a front end. The shards argument on a bindline replicates the listener so that the threads can pull work from multiple listeners for the same application at once, which reduces contention. This is especially useful on servers with many cores and threads in order to make the best use of multi-threading. In version 2.7, this became a stable feature and allowed you to assign threads to groups. So in 2.8, a new global directive called tune listener default shards helps you set the optimal number of listener shards. So instead of using the shards argument on a bindline, this global directive sets the number of listeners to match either the number of threads or the number of thread groups. You can also set it to one listener per process. The per thread group option is the default. So if you want to override the global default, you can set the mode directly on the bindline. When you don't set the shards argument to a number, it expects a value of either by thread or by group. As you can see here, the example, it shows you just those options there, and it's quite simple. Another great addition to the lineup is OCSP stapling. So Online Certificate Status Protocol, or OCSP, is a real-time check of the status of a certificate and is fundamental to the design of extended validation SSL certs. So when a user makes an SSL connection with your web server, their browser normally performs an OCSP check with the CA that issued the cert to confirm that the cert has not been revoked. Because of this extra connection, it can introduce privacy issues and in some cases may create excuse me, momentary delay in the SSL handshake. So OCSP stapling, the client gets a response from the host and it eliminates this CA lookup. Now, previously, this functionality could be achieved only through custom scripts that called the runtime API using the OCSP response method. But 2.8 includes improved support for OCSP stapling and makes it much easier to deploy and manage. So there's two new global directives that give you control over how OCSP responses are updated. So there's a minimum delay directive and a maximum delay, a maximum interval directive. There's also two new runtime API commands where you can request the response of OCSP immediately or view the expected time for the next update. The original show SSL OCSP response method also got a refresh so that could show you response data in text format or as base 64 encoded string. If we look at some examples of this, it's actually quite simple to configure this. First, you need to add your cert list to the SSL configuration if you haven't already done this. This file designates a list of PEM files and optional configuration for each certificate you host. And the second step is to add OCSP update on to any certs that you want to set up for stapling. If you don't specify this, the default is off. This option can only be used in a cert list line. So this applies only to one certificate at a time. And as a result, if you have that same certificate used in multiple cert list files, you want to make sure that they have the same values, or else you'll get errors. When we look at the responses here, it's very easy to follow what's happening here in the log files, or via the API, the runtime API. So anytime the update response is run by the API or called within the configuration, you will get a log line that looks like the first example. So it'll tell you that the update was successful and which certificate it was. If it fails, there'll be two log lines, one for the failure and one for the HTTP related information. So those things all add up to being able to enable this within version 2.8, and it's very, as you can see, very simple and easy to set up. Now, there were some additions that were not covered in this list so far because there have been quite a few. So here's a list of some other features we couldn't cover today, just in respect of everyone's time. There are things such as the new signing algorithms for TLS, where you can specify the signing algorithms that HAProxy supports for digital signatures used in TLS handshakes and client cert auth. There's new and updated global directives to help you with the best performance for HTTP2 protocol. There are 10 new HTTP after response actions, and all of those actions have a new general purpose counter. It's now possible to change the number of sticky counters available without recompiling, so you can do that within the configuration. There are new parameters that have been added for fetching URL and body data. There are two new fetch methods to find the round trip time between HAProxy and the backend servers. So it's going to be very helpful. The runtime API received updates to several of its methods. There are two new preprocessor functions to help you do your configuration based on conditional logic. And finally, there's a new integration with Let's Encrypt acme.sh to enable populating TLS certs in HAProxy. This is a pretty exciting update, so we will publish a separate blog post soon on how to configure this integration. So in terms of the roundup, this is all we had scheduled for today. We kind of whipped through it, but happy to answer any questions that you may have. All right. I do not see, well, there's one. One question came in, will there be a Lua extension for things like Slack? To my knowledge, no. At this time, if there are hooks that you can use to call it, that is something you could potentially do by yourself. But to my knowledge, there is nothing there on the docket for that. If that changes, we will definitely let you know. There any other questions that come in? Do not see any. Oh, there's another question came in. Are there any plans for more events to subscribe to besides server events in Lua? That is an excellent question. That is something that I will have to follow up on. I don't know the specifics around that, but I would assume so, because there's obviously a lot of specific things that have come out recently. But we'll definitely follow up with you on that one, Dominic, and publish that if there are additional ones that will be planned. Yeah. If there are no further questions, that will be it for this version of the Roundup. So I appreciate everyone for watching, logging on, and hope you have a great day. Thank you very much.